Hello everyone, so this is lesson 2 in unit 3 where we will be covering conditional statements a little bit further. So this lesson should follow, if you are on pace of course, your conditional statement classwork that we did as a group. So there might be some repetition in today's work, but remember, repeated repetition in reasoning is part of our mathematical understanding. Now, a few housekeepings before we get started. I am filming at home, so if you hear my Frenchies snoring and, making noise, apologies. I'm really sorry, but this is the only time I can make these videos. All right, so have your highlighters ready, have your pencil ready to go. Let's get started. Notes, starting with conditional statement, a statement that can be written in if-then form. We are making sure we see these terms clearly stated in order for us to know that we are entering a conditional statement. The symbolic form of this is the use of an arrow. So if P stands for the if, the Q is the then, this is the shorthand notation. This reads as if P, then Q, or P implies Q. So basically this arrow means the then or the implies, okay? The hypothesis is the phrase that immediately follows the if statement. And then the conclusion is the phrase that immediately follows the then statement. So let's do a few examples and see what this is referring to. So for question 1, in the examples, the directions read, identify the hypothesis and conclusion of the following conditional statements. So first off, procedurally, I want to just read my conditional statement. If you live in Nashville, then you live in Tennessee. So if is my indicator of a hypothesis, and then is the indicator of my conclusion. So that's way too thick. You living in Nashville is the hypothesis, and the conclusion is if you live, then you live in Tennessee. So that's all I really need you to do here. You're going to write the hypothesis there, and you're going to write the conclusion there. Don't be lazy like me and just draw arrows, because I'm just trying to make this video not super long, okay? All right, next one. So again, I'm looking for those logic markers. If the sum of the measures of two angles is 90 degrees, then they are complementary angles. So here's my if, and here is my then. So again, it's not just about reading, it's about making sense. So if the sum of the measure of two angles is 90, meaning if I add up two angles and they equal 90, then they are complementary angles. This is my conclusion. And that is a correct statement, for sure. So this is where both of those would go. Next, we have if a quadrilateral is a square, then it has 4 right angles. That's really important there. So again, my hypothesis is if a quadrilateral is a square, my conclusion is it has 4 right angles. Now, please make sure that, again, you're not drawing the arrows like me, you are actually writing it out. If you are not, like when I do my binder check, at least for my class, if it's not written out, you don't get credit. All right, so here is practice 4, 5, 6, 7, 8, which I want you to do independently. It's basically the same type of practice we just did. Write each statement in if-then format. Notice that there is no if or then written here, so I want you to do that by yourself, and then check if you're in class with the binder in the back, or if you're doing this at home, make sure you check your work at the beginning of your independent work time when you get back. Okay, I will see you in the next lesson. See you soon, bye. Okay, so continuing on from the last lesson, we're going to talk about conditional statements and a few different types of conditional statements, basically. So we have an inverse statement, a converse statement, and a contrapositive statement. Let's take notes on each one. Starting with inverse. Inverse is formed by negating the hypothesis and conclusion. Negating means proving something is wrong. The symbolic form of this, if you do happen to see it, is this little squiggle. P, your arrow, and then squiggle, Q. You'll see what I mean by this when we actually do more practice. A converse statement is formed by switching the hypothesis and conclusion. So in the previous page, we had the hypothesis come first here and after if. However, with a converse, our hypothesis will come second. So the symbolic form of this is now Q to P. They just switched it around. And then a contrapositive is formed by negating and switching the hypothesis and conclusion. So the symbolism for that is our little squiggle. Q implies not P. By the I say squiggle, but this does mean not, right? I sometimes get in the bad habit of not using the most direct math vocabulary, and that's only because like when I struggled through some of this stuff, I had to make my own, I guess, vocabulary or glossary to help me understand. So apologies if I'm not being super official. Okay, so that being said, I really like these types of problems because I think they're just like a puzzle. There's no math involved in terms of, you know, adding or subtracting, whatever. It's pure logic. So if you're thinking of going into something like computer science or law, like this is really, really important stuff. You will have to study inverse, converse, and contrapositive statements when you are coding or, you know, with a law case. So as Minnie is killing me. Minnie! I'm sorry. So let's read the directions. Write the inverse, converse, and contrapositive of the following conditional statements. Determine the truth value. If false, provide counterexample. So this just means make it true, and we'll talk about what this truth value means. It's really not that intimidating. So let's begin. Let's just do an example. Best way to learn. If it is Saturday, then there is no school. So the inverse of this would be to put not in front of them, right? So if it is not Saturday, then there, oh, you know what? Let me not do cursive because I know you guys don't like it. Then there is school. See how I took both of these statements? Like this one was a positive statement, so I had to put not in here. And then there said there's no school, so I had to do the reverse of that. So if it is not Saturday, then there is school is the inverse statement. The truth value of this is that this is simply false. Like we can give a counterexample to this. So if it's not Saturday, right? Think of that. If it's not Saturday, it can be any other day, then there is school. Well, what about Sunday? What about holidays? So that's just what truth value means. Next, we have the converse of this. So this is just about switching the hypothesis and conclusion. So my hypothesis came first and my conclusion came second. So let's switch them. If there is no school, then it is Saturday. Okay, take a moment, absorb that. If there's no school, then it has to be Saturday. Now that is a false statement because again, Sunday exists, holidays exists, winter break exists, summer break exists. Okay, next we have a contrapositive. Now contrapositive, we are doing both things. So you gotta be really careful with making sure things are in order. So contrapositive, I'm switching and putting the opposite value there. So let's do it. So switching, if there is school, then it is not Saturday. Okay, so basically I combined things happening. Let me use a different color. I used this statement and this statement. I basically combined them to create my contrapositive. And let's examine if this is true. If there is school, then it is not Saturday. That's true. Because school, at least for us, at least here, does not happen on Saturday. Okay. Next up. So you guys are going to do the next two problems by yourselves or with a partner if you're in class, if you really want to. Treat these as like fun little puzzle things. They're really fun in my mind. So yeah, I'm going to pause and come back for the next bit and check your work. Okay, see you soon. Okay, so in the last part of this lesson, we're going to talk about biconditional statements. Now, here's a little caveat before we start. Biconditional statements can be tricky. It just depends on how this material, how you're connecting to the material, really. So here's what I want you to think about when we move through this. Give it your best shot, really just your best shot to try to understand what's going on, and ask for help where you need it. There is no need to like memorize what a biconditional statement is or to memorize basically the language. Think of it as just good logical practice. So let's go ahead and define biconditional statements. It is the conjunction of the conditional and its converse. Now this word, conjunction, nice and fancy, means it is a connection, right? We are connecting them. So the symbolic form, this means conjunction, by the way. I'm using the same color, so you know that that's what it corresponds to. The symbolic form is that little caret sign up, and this statement right here. You see how the arrow is going both ways? That's because we've connected the conditional and its converse. Now, if you don't remember what conditional and its converse means, you might want to just have that other piece of paper near you so you can refer to it pretty quickly. Okay, and we read that as P if and only if Q. So there's a conditional here. P is true if and only if Q is true. This is a very loaded statement. There's not a lot of leeway here to be like, oh, well, if there's a small little exception. No, it's absolute. Okay, so truth values. Biconditional statements are true when both conditional and the converse are true. All right, so again, let's dive into it and just do an example. The directions here say, given the biconditional statements below, write both the conditional and the converse. I'm going to highlight that. I need to write the conditional and the converse. Determine the truth value of the biconditional. Explain why it's true or false. And again, reiterating, biconditional just means it goes both ways. Both ways is true. So my first example reads, two angles are supplementary if and only if the sum of their measures is 180 degrees. So the conditional rewritten, which we just covered, is, okay, if two angles are supplementary, then the sum of their measures is 180 degrees. Okay? Take a moment to pause the video and absorb what was just written. It's based off of this sentence. Now, let's determine the converse of this. Remember, converse is you switching them. You're just switching the conclusion and the hypothesis. So if the sum of their measures, of two angles measures is 180 degrees, then they are supplementary. Take a moment to pause and determine whether that is a true statement. Does that make sense? Sum again meaning you're adding. So if I add two angles together and they measure 180, are they supplementary? Yes, they are. This one was also true. So the truth value to this is true. Both statements are true. Okay? All right, so go ahead and do 2 by yourself. I'm going to do 3 with you, and then 4 you will do by yourself. Make sure you check your work. So this one I wanted to do because now we're actually using numerical values, right? So the conditional statement of this statement, x squared equals 25, if and only if x equals 5. This is where we need to tap into our algebra knowledge. So let's write the conditional statement, if-then statement. If x squared equals 25, then x equals 5. Okay. We'll go back and we'll talk about whether that's true or not. The converse would be me flipping them. If x equals 5, then x squared equals 25. Now, here's a hint. One of these is actually false. Try to think about which one of these is not actually completely true. It's partially true. It's not completely true. And if you're saying that it's the first one, you'd be correct. Okay? The reason the first one is not fully true, because yes, if x squared equals 25, then x can equal 5. But what about if x equaling -5, right? Because -5 squared is also 25, just like 5 squared is also 25. So when I say that this language is really absolute, you cannot ignore other things that would also work. So what I would write here at the end is that it's false. And which one's false? The conditional is false. Okay, that just leaves you guys to work 2 problems independently or with a partner if you're in class, and make sure you check them. If something is not making sense, flag down your teacher and ask. Please ask. Okay, so that's the end of lesson 2 with the conditional statements. I hope you guys had a little bit of fun with this. I got a little bored in preparation for this, so I made you a little collage of my girls. We're proud of you for doing so well and moving along with us on the lesson. We'll catch you in the next one. Bye.